Okay, good morning. Let me kickstart this 5-minute marathon. AI researchers pay little attention to the cognitive processes that they investigate. But if they do so, they will find that cognitive researchers offer no definitive answer as to what is computed. Henceforth, we have the mystery of the mind. For example, in terms of spatial cognition, they talk about a cognitive map in the head of several species, but they keep arguing what the nature of this map is, and so much so that even recently they start to say that there's no such thing as a map in our head, despite a Nobel Prize being awarded to the area of this research in neurophysiology. And for infant learning, for example, they call the baby geniuses because in the first few months of their life, they are able to learn the common sense rules that govern the behavior of the things that happen around them. How did they do that? How can you learn something that's not there? And the mystery of the grammar knowledge is the poverty of stimulus means that it's surprisingly how infants could learn so much more about the grammar despite the poverty of the stimulus. So what happened is what AI researchers do, they implement a version of the theory, they mimic the process, and make it work. So my observation number 2 is AI researchers can't unravel the mystery of the mind using current approaches. Why? Because the immediate problem is not about how, it's about what is computed, and we don't address that. We are very good at making how, but what? What do we compute if it's not a map? What do we learn if it's not grammar? This thing is not working properly. So could we unravel the mystery of the mind? Well, my approach, after about 40 years doing research in this area, I now come up with a different approach. My approach is empower a robot with a basic cognitive process, a very simple process, and then show how the robot could perform the task reproducing the cognitive behavior. So for example, if I have a theory of language, I need to show that it could learn the language like the infants, the first few months, 2 words combine to form a sentence, and then 3 words. And then suddenly, they go very fast, and they learn a lot of sentences. Now, how can I reproduce this behavior? By starting with a very simple process. So the key characteristics of my approach is not focusing on developing efficient algorithms. This is the tenet of computer science. But on reproducing behavior observed empirically. Focus on the behavior. And in the end, here is the differences between the traditional AI and my approach. Traditional AI, given the input, you are concerned with compute what we want to compute. But it didn't update my slide. Okay. But in cognition, we're given the input, we want to show how we are going to use the input to make sense of the world. So we don't compute something, but we use the input. Now, in computer science, in traditional AI, given the input, you have various stages where you make explicit the information you need to finally reach where you want to go to. But in cognition, every stage makes explicit a useful information for you to survive or to act intelligently. So as I realized that now the meaning or the difference between perception and cognition. Perception allows us to sense what is out there. Hence, you compute. Perception delivers what is out there. Cognition is different. Cognition, we got to think about thinking. Every time we have one information, we must utilize the information intelligently to survive. And that is the difference between the two approaches. So by revealing how and what information is used in our cognitive processes has to evolve from simple species to human, we should be able to unravel the mystery of our mind and come to understand who and what we are. Thank you. I still have 12 seconds.